Okay, today is testing multi-part uploads. This is, despite not being the last Friday of a block of content, this is an open-ended, examples, tips, tricks, all that kind of stuff. Doing multi-part forms like we did yesterday, actually I got to finish up the slides of it, is difficult stuff. I don't think it's too crazy conceptually. Maybe that's just my opinion. But it does, I put my thing away too. I actually wanted that. But it does, yeah, sorry for the flashing. Let me not do the flashing. But it does get a lot trickier when you go to the code. So conceptually, it's okay, you got to extract these bytes of the file without converting them to a string, but actually coding that up and getting things to work exactly the way you want it to, it gets tougher. So I added this lecture for starting this semester to just help you out with that code because it is tricky. It gets tricky. So like all these, anything that you're specifically having trouble with, any questions, I'd like to prioritize those. Otherwise, I have my cheat sheet of things that I want to talk about, and left to my own devices, I'll just go through that. Which, for this one, I would expect that more so than others, because we just learned this content. A lot of you are probably still on a homework 2 hangover that you probably haven't started homework 3, being realistic. So I expect more so to be left to my own devices on this one, but I would be absolutely thrilled if there were questions. But I understand if you don't have questions quite yet on this. So parsing multi-part, let's get through the slides first. We have the bytes of a file here, and we need to never, ever, ever, ever encode these bytes as a string. It's going to break the file. We saw that. I did the demo earlier in this semester where I had a file. I just opened the file and saved the file with a different file name, and it was an image file. If at any point in that process those bytes are converted to a string, the file gets corrupted. We no longer have the original bytes of that image that we had. So we need to make sure the same thing here. We have the bytes of an image in the middle of an HTTP request, which gets a bit trickier. How are we going to parse this HTTP request without ever converting this into a string? That gets a bit trickier. And the answer is to parse in bytes. We're moving from string parsing to byte parsing. And spoilers, when we get to next week, we're going to go all the way to bit parsing. That's kind of the progression of the course. It's just parsing lower and lower levels of abstraction. We're going to go all the way to bits, worrying about the individual bits of not a request, but a bytes out of a TCP stream. So we're going to parse in bytes. The trick is never, I shouldn't say never, but not converting this entire thing to a string. For GET requests and for the POST requests we've seen so far, where the body of the POST request was only textual data, we would get the whole request. You receive the whole request from your buffer, and the very first thing you can do is .decode, and that's perfectly fine. Everything works. Nothing really breaks with that. But now we're going to get the entire request, and we can't just do decode. We can't do that anymore because that's going to break our image. It's not going to work anymore. So instead of doing .decode on the entire request, we have to parse this while we're still in bytes. And then after we get the bytes of the file extracted and make sure we're not messing with that, then we can start chopping pieces of this off and converting them to strings. But we're working in bytes these days. Yeah?
Other than the request line, these are each section is effectively its own request, right? That's what it looks like.
Like down here?
Yeah, each section is separated by boundaries, effectively its own HTTP request.
Yeah, it follows the same format, yeah. Mm-hmm. So you can reuse a lot of that parsing code. Whatever method you have for parsing headers, you can apply the same thing on these. Okay, so we're going to parse in bytes. So how do we actually do that? How do we parse in bytes? The good news is, and I said this last time too, but the good news is Python makes this kind of easy-ish, easier than other languages, I'll say. Parsing in bytes in Python has a lot of the same methods that you have when working with strings, so we just use those methods. So the first thing we want to do is look for that first blank line character. We want to look for /r/n/r/n as a byte sequence. Remember, these are all bytes. All these characters are bytes, and they're encoded, they're represented in a way that we think of them as text. We think of them as characters and strings, but really they're just bytes. So we can take these characters that we think of as characters, convert them to bytes, which is dot encode. You've been doing that all along. Encode this into bytes, and then look for this first sequence of those bytes in your byte array, which is going to be right here. Now, mind you, I'm saying the first instance of that, the first instance of that CRLF, that's going to be this boundary that separates your headers and your request line from the body of your request. So the first thing you do, you read from the TCP socket, and you can assume that the first read of your TCP socket contains all of your headers and the first blank line. That's an assumption you can make in this course, not necessarily in general in the world, but in this course, we're going to make that assumption. Look for that blank line, and then parse your headers. Take everything before that blank line as a subarray, a subsequence of bytes. And you know what you can do with that subsequence of bytes? Once you separate this, all this is gone, and you're just grabbing this. It's converted to a string and use all the code you've been using all along. So once you separate the headers, you can safely convert those to a string. Headers, ASCII only. You could even use ASCII. You don't even have to use UTF-8. You know what content this is. And once you parse the headers, then you can start getting more information about the request. That's when you're checking the request line and saying, is this even a message that contains an image? Because if it's not, it might be one of your old requests, old pass from homeworks 1 and 2, that doesn't even contain an image. Or it might be a WebSocket request that we're going to see next, starting Friday, actually, next lecture. So we need to not convert this whole thing to a string, even for any request, every single request. This will go right in our request object. This is why the request class constructor takes bytes. It doesn't take a string, because we can't treat every arbitrary request as a string. We have to treat them as bytes until we know otherwise. Once we know the whole thing is a string, we sure convert it to a string, do your string stuff. But before we know that, we have to treat it as bytes. So starting with this one, we're going to treat every request as only bytes. So in our request constructor, this is where this stuff should be happening. Look for the first blank line, separate the headers, parse the headers, figure out what you're even working with before you touch the body at all. Or as the request class was set up, just stuff the body into an instance variable of type bytes, and then handle that based on what path was requested. Handle it differently. And the first, did I finish that sentence? The first sequence, because guess what? We have CRLF right here, and also right here. Don't split on that /r/n/r/n. Don't split on it, because you're going to be chopping up all of these values. You'll have index 0, index 1, index 2, index 3, and no, not index 4. So you'll chop up your entire request. So look for the first instance of that blank line. Everything before is your headers, everything after is the body, and you don't know any extra information other than that. And parse the headers. In the headers, you're going to find this boundary, and the boundary, you can read it as a string. I assume you're going to send that to your string parsing code. Parsing headers, you probably have written as strings, because it's going to be strings. Get this boundary, extract this value right here as a string, presumably. If it is a string, if it's not, then you're fine. But if it is a string, convert it to bytes, dot encode, get that as a byte sequence, and look for that sequence of bytes in the body, because the body is still going to be bytes at this point. You can't convert it to a string because it contains an image. Look for this sequence of bytes, add your preceding dashes, do all the stuff that we talked about last time, and look for this sequence as bytes in the body. You're going to find those as bytes, separate these parts of the body. You're only going to have one part for your homework. So you're going to get one part like this, get rid of the boundary bytes, get rid of all this, and get rid of the trailing /r/n that'll be at the end of the file as well. You don't want those 2 extra bytes on your file that could corrupt your image, because the boundary is going to be preceded by a /r/n. Separate this, And now we kind of start the process over. Once we have the part separated, we have just the yellow box separated. Now we're going to look for the first instance of a /r/n/r/n again to separate these headers. And I say first instance because this file can contain /r/n, possibly even two of them that looks like a blank line. That can be part of the file. So we don't want to split on that blank line. We want to get the first instance of it, get everything before the first instance, and that's our new headers. And then we can parse these however we want. And to be honest, it's you only have one part for your multipart. So once you extract that part, you know what it is. So I'm not saying you don't have to parse these, but a lot of you will probably get away without parsing them. Because you'll just know what that is. It's going to be the image. Yeah.
What methods can send a multipart? Like,
What methods?
post, delete, put.
I would only use it for use post or maybe put. But technically, I don't think anything's stopping us from using any of them if we use Ajax. Using an HTML form, I think you can only post. But I think if we use Ajax and build our own multi-part stuff, I think we can do whatever we want. We shouldn't. You should only use post or put. But I think we could. Yeah. Yeah, that's why I say shouldn't. You definitely should not. But, theoretically you could. You should not. Absolutely should not. Send a GET request with a body. But like you could, when we did our automated client, when we created a client and just sent any bytes that we want over a TCP stream, like we can put GET and then put a body on it. Should not. We should not at all. But theoretically, anybody. And the reason I would even bring something up like this, like just don't do that. But the reason I bring that up is because an attacker could do that. If you have a vulnerability where you're like expecting no body to a GET request, then there is one, and somehow that allows somebody to inject code into your server. Like people can do that physically; they're able to. But no, you shouldn't by design ever. Oh, those were 116 questions. It's easier in C++, but don't tell Jesse. It's not easier in C++. Trevor, have you given up on C++ yet? Still no. You will eventually. Maybe you won't, but stubborn to the very end. He's using, just for some context, he wants to use C++, and I said, well, Python's required, but if you can get your Python code to call your C++ code, I suppose I'll allow it, as long as it still works through Python. And it's a nightmare. No one should try it. And then once you finally, so you've looked for the first blank line, read the headers, got the boundary, separated everything by boundary, found the part for your image, looked for the first blank line, read the headers. At that point, the body of that part is the bytes of your file. You finally have those extracted, and now you can save that file to disk and do whatever you're doing with that file. So it takes quite a few steps to get to the point where you can separate that file and actually save those bytes, and making sure what you're saving is only the bytes of the file. That's probably one of the bigger mistakes I see in this homework, is getting a little too much, getting the bytes of the file and the trailing boundary or this blank line, or getting a little too much in that file. You should be able to check, if you check the bytes of the original file, like the full, view the data of the file and get down to the single byte, exactly what the number of bytes are, not like 56K or something, but the exact byte number, and then check the exact byte number of the file you saved to disk. They should be exactly the same. If they're off by a single byte, you got something going on wrong here. It might still render the same image, but it might mess up the encodings and might have a corrupted image. Yeah.
Just to make sure that right, you said we won't have that first boundary, so we'll only have 2 boundaries on our homework.
Right. All of this wouldn't exist. Because the form for the homework is just the image. It's not like it's not a text field. Also, it used to be, but this semester, since homework 3 is getting a bit tougher, so image uploads and WebSockets used to be 2 separate homeworks, and I have them in the same homework with more warm up in 1 and 2. So with them both being the same homework, I want to do what I can to manage the difficulty. So it's only the image. But if you had a multi-part form that had multiple inputs, they're going to show up as multiple parts when they're sent. Okay, so now that you have a file, you parse the whole multi-part thing, you do all that stuff, and you have this file, what do? We're going to save that file to disk as that image to disk as a file, and then in your database, just store the file name of that file. So, the difference here, why I'm saying it like that, is don't store your file in your database. I suppose if you do it on your homework, I'm not going to be too mad, but this is against best practices. You should not be storing files in a database, large binary blobs they call them in MySQL, really shouldn't be stored in a database. That's not what databases are good at doing. You already have a file system that's fine at storing large binary objects. Use your file system for that. Don't clutter up your database with that. The database is good at indexing, not storing large amounts of binary data. So don't put that in your database. Save it to disk, and then save that file name only. And you should be coming up with your own file naming convention here. Name your own image files. Don't use the file name supplied by the user. Use image 1, image 2, image 3, and keep track of a counter of the images. Store that in the database. That's fine. Or generate random values for your file names. That's fine too. But you should come up with your own naming convention. Don't rely on your user's naming. Because 2 users upload an image with the same file name. Now what? Everything breaks. Yeah.
How do they say Instagram, or how do they sort of images put on servers and things? Or they just open it?
Yeah, they'll save all those files on a server on disk, and yeah. I mean, I don't know exactly how all their architecture works, but they should not be storing them in databases. Like the database is like a go-between between you and disk, so it'll save to disk in specific ways, index, so everything's very fast, very efficient. But once you're storing big chunks of data, you don't really need that database as the go-between. Just go right to disk, say, I'm going to save this file and this file. And there are services there that you can run like similar to the database that does the same thing, but is made for saving just a whole bunch of files. So if you don't want to maintain like a directory structure, so you don't want to store a million files in one directory, there are solutions to that too that aren't databases. Yeah.
Just kind of like an extension to this question. So like in this on this homework, essentially like when the user uploads an image, that image is going to be like stored on the Docker containers like disk.
Yes. Yeah. And when I say disk, yeah, I do mean inside the Docker container. For testing, it wouldn't be, especially when you want to like check the file sizes. Like I said, when you're running it just with Python, I'd recommend doing that, getting your database set up where you can run just Python, and then moving over to Docker once you know everything's working. But yeah, it'll be saved in the Docker container. Yeah.
Would that be a good practice to name the file name by the name of the user who stored the picture?
Personally, I wouldn't, but for the homework, that's fine. It would be bad practice. The reason why is what happens when you want 2 images per user and they can switch between their profile images. You just disallowed that feature because of your naming convention. But if you just name them image 1, image 2, or with globally unique IDs, randomly generated IDs, then you can just switch to an array of images instead of a single image. And that change is pretty easy to make. But you don't want to back yourself in a corner and limit yourself for future features. That's how you get a feature request and you say, geez, that's like almost impossible. But it seems like a very simple feature request. I want 2 profile images and switch between them. Well, the way we saved our files, our naming convention, doesn't really allow. You don't want to be in that situation. Explain that to your project manager. Or like Autolab, we can't take the highest score, we have to take the latest score because it's a fundamental design feature of Autolab. It's so frustrating and embarrassing to have to say that. Well, the way it was designed. That's the way we got it, but I would not make that decision personally. But are those WebKit boundaries wonky like that specifically so they don't show up in the bytes of the string in the image? Yeah. So the boundaries are chosen. They're randomly generated too, or not randomly. I'm sure there's some algorithm, but this sequence will not show up like in the bytes of your image. Even if you're uploading a massive file, that WebKit boundary will not show up in any of your content of your parts. The browser guarantees that. The browser has to guarantee that. So I think that's why they're long and crazy to make sure that that is the case. But it should be checking. They should randomly generate this. If it were me, randomly generate this and then check all the content and make sure that doesn't just happen to be one of the sequences. And if it is, re-roll, generate a new one, and make sure it's not contained. And then in your database, for our purposes, along with that user's record, if you want to just name them the file name of the user. For this homework, I'm fine with it. I'm not going to be too crazy on best practices because I want you parsing multi-part forms. I think that's hard enough for Objective 1. You're doing enough work. But somehow link that file to that user. If you're choosing randomly generated file names, then for that user in the database for their record, add a value, profile picture equals this image name, just the file name. And then you know to associate that image with that user. So when that user is logged in, authenticated with their auth token, request your home page, use an HTML template. This might be on the next slide. Use an HTML template to inject that as the source of that image. The browser is going to get that HTML and then make a request for that image, and you should host that image on a separate path to be able to get that image. So that's the whole how to do Objective 1, LO1. And I don't know why, but at this point, this trips some students up. That's why I added this slide on it. Just add the image name, the path for the image, in the HTML using an HTML template, like we talked about a while ago. This is the first time you actually need to do it in your homework, but it was a while ago we talked about it. Put a placeholder for, instead of just Eagle, put a placeholder for that, and then replace that. Read the HTML, replace that placeholder with the path for the file name, for the image for that user, and then send that processed HTML, that rendered template, to the end user. Then the browser gets that, sees the source of that image as some path, and it'll make another request. Just like if you hard-coded /public/image/eagle.jpg, it'll be the same thing. It'll make a request for that path. You don't have to put the entire bytes of the image in your HTML. I don't know why, but I see so many students do that for this homework. You don't have to put the entire bytes of the image in the SRC, which is, the browser will handle that and do it. But just put the path name and then get a second request for the image and host the image. And it's this last part, hosting the bytes of that image at a file path. This is the next thing we got to talk about. The next security issue is you're going to have some point where in your server, people can request any of these images. And it's up to you what to do for the paths. I don't specify what your paths have to look like for these images. But you're going to have probably something like this. I would assume more like the first one. It'll probably be get public/image/image name because that's what gels with homework 1, the way we did it in homework 1. You just add more features into that path. Instead of what you might have done is hard code all the images from the handout, from the sample site. Now we want to make this more generic. We want to have some GET requests. You can use query strings if you want, but I assume most of you won't. That's just more work. But take this path and take whatever's after the slash as the file name and send the bytes of that image. Go to your disk, open up that file, and send those bytes. And if that file doesn't exist, you should send a 404. I don't think I put that in the homework doc, so technically not a requirement. That's what you should do. If the file's not found, try to open the file, accept, file not found, return a 404. Is realistically what you should be doing. But we have a problem with this. We have some path, /image/file name. You're going to read the path. You're going to say if method equals get, if path starts with image or /public/image is going to be our case if you set it up the way I expect, which you can set it up any other way. But you're going to check for that path. Does it start with /image in this example? If it does, then everything after /image/ is the file name. Take that file name, open that file, send the bytes of that file to the user who made this HTTP request. Right? That's what's expected. That's pretty much what you have to do. Because we can no longer hard code all the images, bless you, we no longer know how many, even if our naming convention is image 1, image 2, image 3, we don't know how many images are going to be uploaded. So are we going to hard code up to image 50 and hope somebody doesn't upload that 51st image? What are we going to do? We have to use something generic, something versatile like this. We have to have a parameter in our paths for the first time this semester. Right? Oh, no, that's not true. The delete took the ID of a message also. So not the first time. But we have to take a parameter as a file name and send the bytes of that file name to our end user. And then a user submits this. They say, give me your private SSH keys. You're going to just happily, okay, it starts with /image. Okay, everything after this, tilde/ my SSH directory, my private key. Open it, ship those bytes to the requester, and you just unknowingly sent your private SSH encryption keys to the user, and then they can just start breaking everything. They can do whatever they want after that. They can get into your server and just do whatever. So we have a security concern here. We're hosting arbitrary files on our file system, and we want to make sure we limit that to only files that the attacker is allowed to request. We want to limit that. The easiest thing to do for this defense, and the thing I would expect you to do in your homework assignments, is not allow / characters in the file names. And I have to be careful here because I had too many questions about this last time. You can allow slashes in the path, so like /public /image / those slashes are of course allowed. You can have slashes in the path, but everything after your prefix to your path, everything that's part of the file name itself, if you don't allow slashes, which is replace / with empty string is the easiest way to do this, then you're protected against this. They can only access things from whatever directory you're specifying. So if you're saying, give me that file name, and I'm going to look in my public /images directory for a file with that name, and the user can't inject any slashes, only your slashes can be part of that path, they can't navigate to any other directory. Here they're using tilde, which is your home directory / some files. They could go to your home directory still, but they can't do / some file name, / some directory. They can't do any navigation of your file system. They can only request files from the directory that you have coded to be your directory that you're going to use. So if you remove all / characters from the file name provided by the user, kind of like escaping HTML, escaping greater than, less than, ampersand, kind of the same thing. Don't let them use the / character, and they can't navigate your directory structure anymore. They can't request arbitrary files. So that's what I would expect on your homework. Remove all / characters. That's what we'll be looking for in grading. As long as you do that, we're going to consider you covered on this security vulnerability. If you do want to get stronger, like out there in the real world, maintain a valid list of file names or some regex that checks if it's a valid file name. That like matches with your naming convention. If it's image and then an int, make sure it's image and then an int. And if it's not, don't allow it. But have some list of valid files that they can request. And don't forget MIME type sniffing. I didn't put this on the homework, so this one's not required for the homework. Because the profile images should only be sent to the user who uploaded them, this actually isn't a concern for the way the homework's set up. Last semester, it was an image sharing site. You would upload images, and that image would be displayed to all users. So we would have more of a concern here. But you should, as good practice, always disable MIME type sniffing in the browser. Okay, I didn't realize how many slides I didn't get to last time. So let's get into some demo content. Any questions on any of that, first of all? Oh, what's up?
You said to
Let me. Like you're gonna have something like this where you're going to accept any request that starts with public/image, and then if you have a request like that, what you'll do is look for that, remove the prefix, take everything after that prefix as the file name, and then when you have that file name extracted, then you would want to replace all the slashes. Whatever the user provided as the file name, we want to replace. Because anybody actually using this path shouldn't have slashes in the file name. It'll be whatever you put on the front end through your HTML template. So there shouldn't be any slashes in that file name at all. The only reason there would be slashes in that file name is if an attacker is trying to attack you, or somebody's messing with the front end, just to be funny or whatever. But we need to replace those right here. Spoilers, this is what you need to do. Just do that. I want to make sure I mention this at least several times this lecture. So since we're already in this file, here's the first time to talk about it. Keeping your code organized. I mentioned this last time, but there's probably a big question of what the hell does that even look like? Whenever you have a set of features that are kind of distinct from the other features, having that in a separate file is very helpful. So like all my auth stuff is going to go here. All my chat stuff, we have a chat feature. I'm going to put that all in one place. Anything that talks to the database, maybe this is just me personally, but I don't like having database code just strewn throughout my whole program. I'll have a file that has all my database stuff, and then I'll import that code whenever I need to talk to the database. I'll say, hey, database, add this chat message for me. Hey, database, give me all the chat messages in a nice Python list. So I don't have to think about getting collections and getting the database and creating the connection string. Only one time in my code do I ever want to say Mongo client of localhost, Mongo client of Mongo. Then when I want to switch between local testing and Docker testing, I only have to change that in one place. I don't have to change it. Because that's one of the questions that comes up. If everything's in server.py, you don't have to worry about that because you only do it once anyway. But once you start separating things, having one place for your database stuff helps. I won't go through all of them, but one place for my form paths. Requests, you all have the start of a request object, but building a response also. It's kind of the next step. Create a response class that with this one, I'm not clicking on it because I already saw a camera out taking pictures of this stuff. But the response, I didn't actually create a response class for what it's worth. I won't click on it, but I will explain what it is. I didn't actually create a response class, but having a set of helper methods for generating responses is helpful. So in my response class, I have generate response, which is just my generic build a response. Oh, actually, this is helpful. Here's the body that I want to send. It's always going to be bytes because I might be sending HTML. I might be sending an image. It might not be text. So I'm going to send the bytes, the content type, the response code, and if I want to send additional headers, so if I'm dealing with cookies and I need to send an additional header, I'm going to send all that information to my method and have it generate the response for me. And when I want to send that response, this is all files in this method, I'm going to call generate response and then send all response. So each path that I have, first of all, it's not in a big elif, but that's pretty complex to set this up. I'm not even going to try talking about it this semester. I've tried before, and it's confusing. But when I'm sending a response, I'm going to call generate response. That's going to return my response as a byte string. It's going to do all the processing. Content length is the big one. Adding the extra headers and turning that into a byte string, appending the body. A lot of you will have elif and that code pasted, elif, that code pasted, elif, that code pasted. Put that in a helper method. Help yourself out. Put that in a helper method. Add any parameters that you want based on how your responses vary. And then have one method that does that just once. And then your paths, at the very least, having helper methods for the path. Elif, method is this, path is this. Call this helper method, which might be in a separate file, to be able to keep that code separated as well. So my chat, like all my chat paths, are going to end up in this file with all my helper methods, or functions, I guess at this point. I'm used to Java in 1.16 where everything's a method. But all my my functions to handle my chat requests are going to be in that file. And then my server doesn't really have much code at all. Here's my handle method. It's just nothing. It just doesn't really do anything. But even if your handle method does still have if, elif, which would be my expectation at this point. Like you probably will always have that in this semester. Very few students have I ever seen who didn't do the elif thing. But even if your elif says, elif, call this function from my static pass or my form pass or my auth or my chat and separate things into separate files can keep your code so much cleaner, so much easier to maintain, so much nicer to work with. And easier for office hours. If we got to scroll through hundreds of lines of elif, it's just hard for us to help you because we can't read your code either. It makes it very tough. Especially when I do go into the tank and I'm like, okay, I'm going to sit down with the student and figure out what their issue is. It's usually something silly, like that was not a misunderstanding or a lack of your programming ability. It was just because there was so much disorganization that you wrote a silly bug, like a copy-paste bug is often what it is. So it's, I don't know. I don't know if anybody's going to heed these warnings, so I'll stop. But at least try to have better organization. All right, let's get on to some. I have these in order. I don't know why I'm scrolling. No, I don't have these in order. Here we go. Let me start my server. And I have my profile pick form. This is a little different than the handout code. I don't have my encoding type specified. If you don't have an encoding type, actually I'll add it. If you don't have an encoding type, it'll default to form the URL encoded. And I didn't mention this last time, but there's only 3 options for your encoding type of an HTML form. We already saw URL encoded. You did that on homework 2. We're going to see multipart. That's what we're doing for homework 3. And the last one is text plain, which even the documentation, all the official documentation says you should never use. You should only ever use it possibly for testing and debugging purposes. Never ever use it in production. It's just dumping everything in plain text in the body, which doesn't really work for most purposes. So let's explicitly choose URL encoded, which is not the encoding we're using for homework 3. I have a file upload form. I'm running my server. Let's meander over to that server. And here's the testing image of the elephant. We'll see that in a second. I'm going to choose a file. I actually am going to choose that one right away. This elephant small is 479 bytes. It took me a while to get a file that small. It's hard to, like, just standard compression and changing the file size wasn't enough. I ended up, I don't even remember what I did. I needed something. And I'm going to post this. And take a look at what I get. So here's my request. I received a post request for profile pic. That's what I expect, a post for profile pic. I have all this information. I used Opera for that because I'm a dummy. Let's do it again in Firefox. Oh, I clicked the wrong thing. That's a point I want to make, but I did it in the wrong order. So here, let's make another request. Profile pic, post, profile pic, that's everything we expect. And then I expect my data to be URL encoded in the body of this request. We can see our blank line right here. And then the content is just the file name. So this is why we can't use URL encoded for file uploads. The browser will not send the content of the file, just the file name, which is pretty guaranteed not what you want. If you have users uploading images, you don't just want to know the name of the image that they're uploading. So let's delete this. We can't use URL encoded. We have to use multipart. We're going to go back to Firefox. We're going to refresh this page, resend that. Nope, I'm dumb again. No, we're going to get this. I upload like at least half of you got to see what I messed up, right? That was so dumb what I did. I changed the HTML but didn't refresh the page, so I never got the new HTML. What I had in my browser was still the old HTML. So when I just resent the form, it was the old HTML. So this should be the new HTML. We're going to post. Oops, wrong IDE. Wrong project. And there we go. Now we get our request post for profile pic, but now we have multi-part form encoded. So our content type, multi-part form data, we have our boundary, which in Firefox is going to look different than in a Chromium-based browser. It won't have that WebKit boundary. A lot of students like to look for like -- WebKit boundary or whatever. Different browsers can use whatever they want for the boundary. As long as the boundary isn't contained in the actual data that the user uploaded, it can be anything. It doesn't have to be preceded by a bunch of dashes either. So don't make any assumptions about this boundary. It can be whatever the browser decides it can be. The next version of Chromium might even change completely what that looks like. Don't depend on what the boundary is. But once we have the boundary, and I'm not counting all these dashes, but I'm guaranteeing there are 2 extra dashes right here than there are up here. We'll see that boundary and the actual contents of our form. The boundary, our content type and content disposition. And the reason I'm printing this in bytes is so we can look at these new line characters. We have the blank line separating those extra headers for the part, and then the bytes of the image. Here's all of our bytes for that image. That's what we want to extract. This is what we can never convert to a string. And then it will be followed by another blank line. This /r/n, sometimes it corrupts the image, sometimes it doesn't. But having this extra 2 bytes at the end of your image that you're saving can mess things up. This is one of those, well, it worked when I tested it, but not when the TAs tested it. It just depends on which images you're using. Sometimes it does, sometimes it doesn't. Make sure you don't have these extra bytes. Then the boundary, and then a trailing -- on the last boundary, and finally a trailing /r/n at the very end. So if you're looking for that last boundary, make sure you don't try to process this /r/n as another part to your form as well, another part to your request. And I got all of this in one go. If you're using Firefox and you upload an image like this, and the image is small enough, notice it's specifically that this image is smaller than my buffer here, that I'm going to get that entire image in one go. This receive of 2K is going to be at most 2K. So if there's 2K sitting on the buffer to read, or more, I'm going to get the first 2K bytes that are ready to be read. No more than that, but I might get less than that, which is a very important distinction. When we have images greater than 2K, do not do this. It's not allowed. That's not okay. First of all, once there's data to be read, this is going to return. And that might happen before you have the full image. It might be when half the image is uploaded, receive says, yeah, there's enough data here. The buffer's not full, but I'm going to return. So it might not even work. But more to the point, we're going to check this. It's in the testing procedures. If you do this, you bypass the assignment. At best case, the TA is going to make sure they upload with an image higher than whatever number you typed there. Yeah.
I'm not sure if I missed that, but do we have to handle the boundaries differently for Firefox?
No, you handle them the same exact way. But some students try to cheese the assignment, and then they say, well, it worked in Chrome, but not Firefox, because they hard-coded to whatever Chrome does. So we're not going to increase this. For Objective 1, test with Firefox with that elephant small or whatever other image that isn't going to overflow this buffer. And that'll be good for Objective 1. In Objective 3, you'll handle arbitrarily large files. Yeah.
So for boundaries, in the header, it's not guaranteed that there'll be dashes, but like for the actual parts, there'll always be like 2 additional dashes.
Yes.
And
Yeah.
then for the very last part of the boundary, it's always guaranteed that there'll be 2 additional dashes at the end.
Yes. Yep. The extra dashes, that's part of the protocol. That's always going to be there. But the dashes in the boundary itself from the headers, that isn't necessarily always going to be there. course it's gonna. All right, I got to go to Chrome. Of course, it's not going to give me what I wanted to show. I thought since that was Chromium, I thought it did the same exact thing. Well, there goes that demo. That one didn't work. I'll have to upload a larger image, I guess. So I guess this image is small enough that we don't even see the bug. It's convenient, but I was already set up to talk about this, so we're going to do it anyway. All right, so here I have a request. I uploaded one of the more regularly sized images, not that ridiculously compressed image. It was the eagle. I get a post for profile pic. I did this in Chrome. It's a Chromium-based browser, of course. And Chromium-based browsers often do this, what we see here. We have the boundary, we have the headers, we have what the boundary actually is. We have the blank line here. We have, if I can find it, content length somewhere in here. Content length. We have a lot of bytes that should be sent to us. We have the blank line saying this is the end of the headers. And then end of data. That's it. We just got the headers. You're going to see this a lot in Chrome. Apparently not with that tiny elephant image. Apparently things work just fine. But when you're uploading larger images in a Chromium-based browser, it's common to see this. You're only going to get the headers the first time you receive. Chromium's going to send, and I said this